My name is Michał Łusiak, and I'm gonna tell, or Michael, if that's easier for you in English, and I'm gonna tell a few things about cross-platform development in F#. I really like this image from International Space Station because this shows my both homes right now. We're somewhere here. I originally come from here, and now I live here in southern Sweden. I work for those guys, writing C# mostly for the most of the day, and during night I turn into Monster and start writing F#. So when I first wrote the abstract for this talk, I just wrote it very, very wide, and then I realized I just have half hour, so I had to focus the scope for today. So I decided that mission for today will be to just tell you what's F#, how you can write F# for three major mobile platforms, and how do you start this kind of development. So first, few words about the language itself. F# is a multi-paradigm language that runs on a .NET CLR. It was created in 2005 at Microsoft Research in Cambridge. The main architect for F# was Don Syme, and he still takes care of the language. It's been officially released to production in 2010, so you could have it with Visual Studio 2010, but you had to install it. From Visual Studio 2012, it comes baked in as a regular language next to the C#. It's statically typed language, but when you look at this F# code, you don't really see that because it has a very strong mechanism of type inference. So it figures out by the values you add to the variables what kind of type they are. So in most cases, you won't be declaring type you won't be declaring the type. The authors of the language say it's functional first, but it's not pure functional language. They resigned from the few concepts of functional programming to make it more practical. It can be also object-oriented. You could do also object-oriented programming with F#, because it has all the constructs you need for doing object-oriented programming. The whole source of compiler and most of the tools in open source, Microsoft released it. You can just see the source on the GitHub. As I said, in .NET language, which has a few interesting consequences. You can basically use all the code that have been wrote in C# or VB.NET and just reference it from F#. So if you want to start using F# in your company and you already do development in C#, it's very, very easy. You can just, for example, start by writing some small module or library you need and use it with all the other code you have. And it's from 2012, it's a first-class season in Visual Studio and also in XAMARIN Studio. An interesting thing is that XAMARIN Studio has actually much better support for F# than Visual Studio because they pull into their production versions all the cool stuff that F# community is making, and they have much shorter release cycles than Visual Studio. So a few words about XAMARIN. XAMARIN is a company that created framework on top of Mono, which is open source implementation of .NET CLR that allows you to run .NET code on every platform. So what's most important, it allows you to run non-Windows platforms, which was the problem for the C# at the beginning. It's based on the Mono, and it targets basically every operation system and every CPU architecture. And it offers binding to SDKs, so basically you can use like Android SDK or iOS SDK from the XAMARIN code. And even if you have some libraries written in the native languages, you can invoke them from XAMARIN. And the other thing is you have access to the full .NET base class library, which has all the interesting stuff you know already when you did some C# development. And also Xamarin gives you Xamarin Studio, which is a really cool IDE for doing mobile development. So a few words, how does it actually work? How is it possible? For every platform, Xamarin does it a little bit differently. So for iOS, it's compiled ahead of time using Xcode actually. So they use the original compiler to do the compiling. This is because of mostly licensing issues with Apple. And because Apple doesn't allow dynamic code generation, some of the dynamic features of C# and F# are not available this way, unfortunately. And but anyway, you can do most of the code anyway. And it's the Cocoa Touch SDK is exposed in the Xamarin iOS library, so we have access to all the stuff you are used to while doing iOS development, just from the C# or F#. Android is compiled to IL, and then applications are shipped with a very small virtual machine, and then runs on top of the virtual machine. So every time you actually deploy an application to an Android device, you deploy a small virtual machine and then code that runs on top of that virtual machine. And the same as with iOS, the whole SDK is exposed through as a library, and you can reference it. In terms of Windows Phone, it doesn't need any Xamarin tooling because it's compiled out of the box to the Microsoft IL, and then works on the built-in runtime. So basically, you don't need any Xamarin to run to Windows Phone. But if you want to target all the three platforms, you need to have a little bit different approach to designing your application, to have a shared code base with other two platforms. I'm going to say a little bit more about this later. So in terms of development requirements, all platforms are a little bit different. So iOS, mostly because of licensing issues, need Mac running OS X and Xcode for compiling. So either you can run the Xamarin Studio in Mac and then just build using Xcode, or you can do all the development on Windows with Visual Studio, but then you need another machine, Mac with built OS X as a build machine, connected through the network. So it's possible, but it's a little bit hard to do. Android is the easiest one of those three because you just need Java and Android SDK installed, works on all platforms. So you don't need any special account to build your applications. You don't have to pay any money to do that. And it works both on OS X and Windows. And Windows Phone works only on Windows 8, so that's another problem. So you can, when you're running your all three projects, you can actually see like Windows Phone code in Xamarin Studio, but you cannot build it. So actually, if you want to target all three platforms, you need both Windows and Mac, which is kinda stupid, but all about licensing, I guess. And about sharing code, there are basically two strategies you can do to share your code. Either you have a shared project that is used during build, and this project has all your business layer, data access, service layers, all that stuff that can be shared. And then you have three specific platform-specific projects that allows you to do platform-specific stuff like UI and some using some kind of hardware that's only available for one platform, for example. And the other strategy that came to F# In the latest release of Xamarin Studio, it's still a little bit experimental. You have to say that, yes, I want to use this experimental feature to use it. It's a portable class library. It's built as a DLL, and then your other project reference it. Yeah, they're really similar, but the first one is a little bit easier to do in terms of development. The other one gives a little bit nicer architecture. That's the most difference. And I said a few things about UI, because until recently you have to do UI specifically for each platform. But recently Xamarin released Xamarin.FORMS that allows you to write, they created language that's abstraction over over most of the UI elements. So you write some code and to build UI interfaces programmatically, and they use their logic to run the UI specific from the platform. So if you use a map control, you get iOS maps on iOS and Google Maps on Android and Bing Maps on Windows Phone. If you use some tabbed view, you get tab view on Android and iOS, and you get panorama view on the Windows Phone. And they basically wrote code for around 30 of the UI elements. There are still some UI elements that don't translate well between platforms, so you can mix. You can use Xamarin.FORMS and then use some native code. So it gives you even more chance to have more shared code between three platforms. And that's example of doing some label on the content page in F#. One of the, I think, most simple UI elements. And then you need some code platform specific. For example, this is for iOS. The least amount of code you need to run some iOS apps in Xamarin, this is app delegate. If you do some coding in iOS, you probably know what app delegate is. If you wrote, for example, for Android, you have to do some activity code. And then those two code snapshots put together give you this. Actually, not true, because this will give you the iOS part. You have to build the platform specific for the two other platforms. And yeah, that's it about iOS forms. I want to get back to F# a little bit, because I really like this language, and talked about three of my favorite features. If there are some Haskell or OCaml developers here, they probably say we stole it from Haskell and OCaml, and they are true. So one of the things that's really cool for programming is pattern matching. It's basically, if you know Switch from other programming language, it's like Switch on steroids. It basically allows you to pattern match strings, numbers, lists, complex object, and do all kind of operations on that. One of the cool stuff is that if you do a pattern matching that doesn't cover all possible possibilities, then it will give you a compile error. So this lets you know about some cases you could forgotten about, and then give you less bugs in a production. Right. Other thing I really like is units of measure. Somebody told today about the Mars mission that went down in flames because of units of measure. Yeah, if they use F#, they didn't have that. If they use a Haskell also. So basically you can do that like subtype information. And so because these are floats, F# will figure out these are floating numbers, but then we'll have the subtype information, the unit of measure. So if you try compare two numbers, which are technically both floats, you cannot compare them because there are floats of different units of measure. You have to use like some conversion function to compare them. Otherwise, it wouldn't allow you. The same with like doing mathematical operation on those units. The whole operations you do have to make sense from the unit's point of view. And you can mix your basic units to do more complex units, just like in physics. So it's very useful for some physics calculations. Also, we can use the units for measure, for example, for doing currency conversion. So people at finance also loves this feature. And other thing is, I'm not sure if this is stolen. This is type providers. So that's the way to put some additional type into the compiler at the runtime. And this works without any dynamic code generation. They're just injected in the compiler. So this is one of the simplest. This is JSON type provider. So you, for example, get some JSON from some website, from some API. Then you have to add to the parser sample of this JSON. So it's now what kind of stuff it has to parse. And then, if you're doing development in Visual Studio, probably know what's IntelliSense. It's something that gives you, after dot, information of all the methods or fields you have for any object. So .NET developers like to say it's dot-driven development because you press dot and figure out what's next. And you can do that because then you treat JSON, which is like string you got from the internet, as a statically typed object that you can do some operation on it. So this is a very simple type provider because JSON, it's not that magic. It's basically JavaScript has out of the box, it treats JSON as an object, right? But there are type providers, for example, for SQL, so you can, during development, you can press dot and traverse through tables you have on database, through the relationship between tables, etc. So you get basically strongly typed SQL inside your code. There's type provider for Facebook, so we can traverse through a friend tree on the time. And the way it happens, like every time you pick something from the list, it goes to internet, gets additional data and injects it into your compiler. The last time I looked at the list of available type provider, there were around 40 of them. But it's not rocket science to write your own. So because the F# community is very, very productive, they do a lot of this stuff. They're also very friendly, so if you would like to start and ask stupid questions on Twitter, they are very, very, very nice usually. So yeah, why F#? Usually, the start is a little bit steep, but then when you start writing more code, you write less boiler code. You don't get any parentheses or curly braces. Because F# looks a little bit like Python with spacing used for scope. And with less code, you can write more, focus more on the problem domain, the problem you're solving. And statistically, if you have less code, you have less bugs. And then with the features, the three I showed you, but there are many, many more, that cause that F# code usually has statistically very low amount of bugs. People who use F# in production tend to say that it's very fast development, and you can get to market with your product much quicker. And one more thing, because this is functional language, so if you use if you keep your architecture functional and you write the code in a nice way, it's very easy to parallelize, which is important in times when we reach the physical border, how fast can CPUs be, and we're going into multiple cores. And as I mentioned, if you already run your company on C#, it's very easy to start. There is basically no no barrier in it. So I'm gonna give you some links for where to start with all that fun. First one is basically like website that has an interactive F# window, so you can type F# on a website without installing anything, just to start playing with it, see if you like it. The other one is a set of failing unit tests that you need to fix to make it unit test work. So like within 2 hours you get a chance to understand F# syntax just by fixing some errors in code. I really like that approach, and it works really nicely. It gives me a kickstart with working on F#. Third page is more about reading stuff, how things work, how you should approach them. Very interesting if you already are not beginner, but would like to understand things that are the deep dive. And F# Software Foundation is a foundation that takes care of the F# source. And they also have a lot of learning resources and technical talks and all that stuff. And if you want to do a development with Xamarin, they have great guide on their website, how to start, how to prepare your devices, everything basically you need to start development. And if you prefer to get knowledge from technical talks, these are a few I really suggest. Yeah, I'll put on my blog, and probably put link on Twitter, so you'll be able to click those and get this to start. And I think that's all from me. So thank you, and I'm happy to take questions. I have T-shirts I get for good questions. All right, so if you'd like to talk later, I'll be around. Oh, we have questions, sure. Sorry, I didn't see you.
If you compile to those 3 platforms, what's the size of the executables or of the packages of the applications compared to a Hello World that you would write natively for those platforms?
iOS is the same because we use built-in compiler. Windows Phone is the same. Android is slightly bigger because we ship the virtual machine with it, but it's not that big of a... probably with the Hello application it will be large bigger because the actual code is not going to be that much. But with a bigger application it's probably not significant.
How about the size of the common class library? The thing that makes it portable.
I don't know actually, but it really depends on how big code base you have. But I don't think it's gonna be significantly bigger, because what those compilers also do, they strip all the classes you don't use anyway in your code. So it's not that like you build whole .NET into your application.
So this DLL is not going to be packaged along with your application?
Yeah, DLL is going to be packaged because it needs to reference it. So the packaged application looks like built natively. So they get those APK files or whatever it is for the platform. So it's after it's built, it's completely unrecognizable by the platform that it's been written in a different way.
Hi, maybe I missed it, but can you distinguish the devices when you write the code so that you achieve something that is actually per device, so per Android or per Windows or something?
Yes. So either with shared project approach, you can use compiler directives, like if Android, and then you have there is some code to support like specific devices to do stuff that is possible for some devices, especially important for Android because the ecosystem is so large and devices have so much different possibilities that there are libraries that support that and help you target different devices. Oh, here's the question, right?
Hi. Android application, the package contain a virtual machine. Can you say 2 words about performance of it?
To be honest, I don't have actual experience with working Android. I mostly build applications for iOS and Windows Phone, so I don't have hands-on experience with that. And I never heard of any problems with that, but I can tell you from my own experience. Sorry. All right, cool. People who ask me questions, grab me later. I have T-shirts for you. And if you'd like to talk about F# or working in Sweden or anything with me, just grab me. And yeah, let's talk. Thank you.